Hello, this is Dr. Michael Hassan, the engineering doctor, and this is lecture number 31, the clocked SR flip-flop of chapter 6, flip-flops of the course Digital Logic Design or Digital Systems or Digital Electronics. The next slide is a disclaimer for you to read. There are many references in Digital Logic Design. I cite 3 references here. In chapter 6, we covered sequential networks, memory elements, the SR flip-flops, and today we'll talk about the clocked SR flip-flop. The clocked SR latch, practically sequential systems are synchronized with an external clock. Therefore, clocked SR latches and flip-flops are often used. A clocked SR latch is designed by adding 2 steering 2 input AND gates to the NOR gate latch or changing the 2 inverters of the NAND gates latch to steering 2 input NAND gates as shown. Now we have seen actually the cross-coupled 2 NOR gate circuit and the 2 NAND gate circuits in lecture 30, so please refer to the lecture number 30 if you did not listen to it. The steering gate are used to control the application of the input signals S and R to the cross-gated latch, and basically they will be controlled by the clock pulse, and the clock pulse will basically enable the set and reset signals to get through the latch. Now the simple diagram of the block diagram of the clocked SR latch is shown here. We have the input S, the input R, and clock pulse CP, and the output Q and Q prime. And the hardware circuits for the 2 NOR gate, we added 2 AND gate, 2 steering AND gate, 2 input AND gate, the clock pulse along R and S, or 2 NAND gates with the clock pulse along an S and R. Pay attention please that R on the upper side of the circle, of the north circle, and S on the lower side, and vice versa with the NAND gate circuit. Now the clocked SR latch, the truth table is identical to that of the unclocked SR latch, except the clock pulse will control the signal. So note that between the clock pulses, when the clock is 0, the outputs of the 2 steering AND gates are 0 independent of the values of S and R. Therefore, the inputs applied to the 2 cross-coupled NOR gates are 0. Hence, the state of the flip-flop does not change. That's Q plus is equals to Q if the clock is 1. The outputs of the 2 steering AND gate and this are the same values of S and R, and clocked SR flip-flop acts according to the truth table shown. So if the clock pulse is 0, if there's no clock, or during the 0 interval, so regardless of the value of S and R, there will be no action, and Q plus will be equal to Q. If we have a clock pulse and S and R are zeros, this is the hold mode, and Q plus will be equal to Q. If we have a clock pulse and 0, 1, this is the reset mode, and the Q plus will be equals to 0. When S is 1 and R is 0 with the clock pulse, the output will be 1. And this is the set mode. When both ones, those are invalid inputs, because we know why. It will generate invalid outputs, where Q prime will be equal to Q, and we have to avoid this. So with the clock pulse, those invalid input. So this is the truth table of the clocked SR latch. The timing diagram, again, with the clock pulse, has to be available for S and R to get through. So at the clock pulse, we will look at the state of S and R. S is 1 and R is 0. The output will set to 1. Initially, the output was 0. It will set to 1. At the next clock pulse, we see actually that R is 1, but S is 0. So the Q will reset, to 0. Q will reset to 0. And the next clock pulse, we see no inputs. Okay, both are zeros, and it will remain 0 because it is 0. And when there is no input, will be the hold state. So it will remain 0 at the next clock pulse. So Q plus will be 0, which will follow the value of Q here. Okay, so the timing diagram is simple, and the clock pulse will control the passing of the signals S and R to the latch. Master-slave SR flip-flop. Due to their physical difficulty, SR latches are not appropriate for use in synchronous sequential networks, since this difficulty may cause unstable behavior. One method to prevent such behavior is to cascade two set-reset latches in a master-slave architecture. The input latch is the master, cascaded with the output latch known as the slave. The figure will show an SR flip-flop designed by cascading two SR latches. When clock is D0, the master latch is in the gated mode, which will be enabled, allowing its output Qn, which is Q master, to change according to the inputs S and R, while the slave is in the hold mode, which is disabled, ignoring any changes on its input. When the clock is 1, the two latches exchange roles, and the slave enters the gated mode, sending Qm to the flip-flop output Q, when the master latch enters the hold mode, ignoring any further changes on its input. So we see the hardware circuit here. We have the master with output Qn, and we have the slave with an output Q, which is the output of the flip-flop. The clock pulse is inverted, okay, and inverted again. And this is, basically the flip-flop shown is a positive edge triggered. Okay, however, if we short circuit the first inverter, which is this one, the clock, okay, if we ignore the inverter, and the slave is not inverted and the slave clock is inverted, the SR flip-flop will behave as a negative edge triggered, So the beauty, we can design the flip-flop as positive edge triggered. It means the change will occur as the clock changes from 0 to 1, or a negative edge trigger will allow me to make the change as the signal changes from 1 to 0, as the clock pulse changes from 1 to 0. So this is the reference. This is what really we call it flip-flop. Once we have the master slave, it is a sophisticated circuit. It's more stable. It is either negative edge triggered or positive edge triggered. It is not level sensitive, and the stability we achieve from this flip-flop make this flip-flop is much better than the normal latch. Okay. Now this is the end of this brief lecture of SR flip-flop. Now, by designing a master-slave configuration, we transitioned from a simple latch to a flip-flop circuit, which is a more stable and is an edge-triggered circuit. I would like to thank you so much for listening. Please subscribe by clicking on the blue circle, and hopefully to see you soon. Sincerely, Dr. Hassan.